really quick, a quick disclaimer about this unit. We are down to, I have 7 weeks to do 2 units. Well, I really have 6 weeks to do 2 units. We usually spend 4 weeks on 1 unit. Now, we're not going to go very fast, but I do need to jump around a lot. What I mean is we're going to skip this, we're going to skip a lot of things in this note packet. So this is the same note packet from last year, but I didn't need to skip anything last year because I had time. This year I'm running out of time, so we may skip, like today we're going to skip the first 5 pages. And I do apologize if you printed the packet at home. You just now for this unit and next unit, you just kind of got to bear with me with the jumping around just because we are in the last 6 weeks of school. The last week of school is going to be time for you to make things up. So we're in the, I only have 6 weeks to do 2 units with you, which is nobody's fault by any means, but we are just going to have to skip around a lot. So I will make sure that this flows as nicely as possible, but I don't have to teach you all of this, and there's some examples that we're going to skip. So this is just my disclaimer going into the unit that we are going to skip some pages, and I just need you to be flexible with me, okay? So I do apologize if you did print this packet at home. There's going to be probably about 1/3 of the pages that we don't use, but we still, I didn't have time to remake the whole notes packet. So we're gonna, and some of these decisions, I'll be like, oh man, I don't have time to do this on Friday, so I'm just gonna cut this out. So some of the decisions may be a last minute thing. So I'm not even sure yet what we are gonna cut out completely. So with that being said, we are going to skip ahead already to page 6. I will make sure all of this will get repeated throughout the week, so you're not missing any important information that you are not going to not learn. I will make sure to teach you all of this information throughout the week, but just as a one good place to start, we are going to start on page 6. So whether you have the packet, you printed it, you were taking notes on a piece of paper, or you printed it to OneNote, please be on this page. It doesn't have a clear title, but you want to be on the top of page 6. It looks like this. All right, so I'll give you just a second to get there. Alrighty, so there's a lot of reading to do on the page 5. We are not doing page 5, but I will summarize everything that was just said on page 5. This unit talks about logarithms, and logarithms is something, it's not a difficult concept whatsoever. Logs is another math expression that we can learn about. This may be your first time learning about logs, and we will take it slowly. But what logs is important, one, you use a lot of logs in pre-calculus, which most of you are going to next year. And logs is what you see a lot of on the SAT, which is also what you will be taking at this very time next year. Juniors are taking the SAT next Tuesday. Which you guys are not, of course, because you're not juniors, but next year you will be needing to worry about this, and you will see a lot of logs on the SAT. So we are going to jump into it. And logs, we are going to be, today we're going to be talking about going from logs to exponent form. You have seen, so I'm going to start going through the notes on page 6 now. You have seen this before. 4 squared equals 16. You have seen that before. 4 squared equals 16. You know that. This is called exponential form. So this is exponential form. Anything with an exponent. You are familiar with that. Exponential form. Right, so everything on this side, all of this is an exponential form. 4 squared is equal to 16. 4 to the first power is equal to 4. You could put that all in your calculator. 4 raised to the 0 power is 1. Your calculator can handle all of that. Okay, what you haven't seen, or maybe you have before, but most of you haven't seen, is this side over here. This side over here is logarithmic form, excuse me. So that word is right here, logarithmic. So this on this side is logarithmic form. Whoops. And today, all we're going to practice today is going from one form to the other, and I'm going to teach you how. So I can take the exponential form, which you are comfortable with, and we can go to log form very easily. And by following this. So we are going to do all these examples in a second, but the key formula you need to know is log of base b, so log of some number of x equals y. Logarithmic form is equivalent to, if I want to make that go to exponential form, it's equal to some number b raised to the y exponent equal to x. So in order to go from log form, remember this is log form, log to exponential form. This is exponential form. So we're going to do a whole bunch of examples right on top. Today, the whole rest of today is going to be examples. Practicing how do I take something that is in this form and write it in exponential form, and vice versa. How do I take something that's in exponential form and write it in the form of a log? We're going to practice going each way. Well, we have something to go off of. If I have a log, the log of some number base b of x is equal to y. So let me go read this to you. So if I have, excuse me, let me do log 4 x equals y. The way we read this is the small number that's after the word log is base. So we read this out loud as log base 4 of x is equal to y. So the number here is the base. So think of b standing for base. Log base 4 of x is equal to y. So b stands for base. So whatever the base is equal to the number in the exponential form. The number that's set equal to the number on the other side of the equal sign is the exponent, right? Because they're both y. And then x, whatever your x is, whatever comes after the base is what it's equal to in exponential form. So I know you're confused right now, but we're gonna just practice all day long today. We're gonna practice all day long. What I like to do and what I've always done, and it's always stuck, when you go from log to exponent form, I always do this little motion. So to go from log to exponent form, I always draw these arrows. I go from the base to y, I draw base to the equal sign, and then from the equal sign to the x. I draw something like that because that means I do the base raised to the y equals x. That's how I remember how to do this. And if you notice, that's what this means. Base raised to y equals x. So if you follow these arrows, you will get it right every time. Base raised to y, base raised to y equals x. If you remember that order, you will get it right all the times. All right, so let's just do a whole bunch of practice. All right. So the key for today is this formula, how to go from one to the other. Make sure you have that written down. All right. So I have 4 squared is equal to 16. That's this first problem. So if I want to go to log form, this is exponential form. So log base 4, so what this is saying is the number. So I want to go, what I'm doing is I want to go from this form to log form. So I need to match up some of the things. I'm going to always put, I have the base is the number, the big number. So 4 is B. If I'm matching 4 squared equals 16 to this, the number is B. So log of 4. So the base is 4. Then the y value is going to be, my y value is going to be my exponent, right? In exponential form, by is equal to x. So 4 squared is equal to 16. Then the y value here is equal to 2. The y value here is equal to 2. So in my log form, when I have my log form, I'm going to write it over here, log of b, log base b of x is equal to y. Well, where do I put the y then? I know that my y value is my exponent, but when I go to log form, my exponent is going to always be on the other side of the equal sign. My y is my exponent in my exponential form, but when I go to log form, my y is going to be on the other side of the equal sign. So what belongs on the other side of the equal sign here? It needs to be my exponent. So my exponent here is 2. So 4 squared equals 16. When I want to write that to log form, I write log base 4 of 16 is equal to 2. Oops, keep that 2. Same thing here. I have my exponential, I'm going to erase this. I have exponential form is 4 to the first power equals 4. So comparing that to exponential form, my b is 4, my y is 1, and my x is 4. Putting that into my log form, I would have log of b, which my b is 4, of x, my x value is also 4, equals y. My y value was my exponent, so my exponent was 1. Okay. Same thing here. 4 to the 0 power equals 1. So whatever goes on the other side, when I'm going from exponent to log form, whatever goes on the, what I always want to remember is what goes on the equal sign. What goes on the other side of the equal sign is the exponent. So I'm missing what goes on the other side of the equal sign. So I'm going to, as I get better, I'm going to remember that what goes on the other side of the equal sign is the exponent, and the exponent is the tiny number here, and the tiny number here is 0. I'm going to put a 0 there. Righty? And it's a lot of repetition. Same thing here. I'm missing, to go to log form, I'm missing what goes on the other side of the equal sign. I know what goes on the other side of the equal sign is always my exponent in the exponential form, and my exponent is -1. My goal is for you to start to find patterns. And one last time, again, to go to log form, I'm missing what goes on the other side of the equal sign. What goes on the other side of the equal sign is always my exponent, and my exponent here is -2. Okay, it's not so bad so far. I think it's even easier when I don't give you half of it already. Here I've given you half of it and I tell you to just come up with the end. I think it's even easier when I tell you to do all of it. Alrighty, so what we are going to do is we're going to do a whole bunch of examples on the other side. One thing I want for you to know, what it's saying down here, is it says, please note, when a log is base 10, we don't write the base 10. So anytime, so right there, we were just working with log of 4 of 2 is equal to 16. Let's just say we had that. The base is always, the base of this log is always that tiny number. I want you to get used to that. The base of this log is that tiny number right there. Log base 4 of 2 is equal to 16. That's how we read that. Okay, so what this is saying, when the log has a base of 10, when the log has a base of 10, when the log has a base of 10, we usually don't write the 10. So anytime you just see log 2 equals 10, anytime you don't have a base, it is standard that the base is 10. Just like if there's no exponent, if I said, hey, x plus 1, what is the degree here? You would say that has a degree of 1, but we don't need to write that 1. That is now, I want you, whenever you see a log that has no base, its base is 10. We just don't usually write the 10. So that's what this is saying. When a log has a base of 10, it is common not to write the base. So these are the same thing. You will absolutely see that on your SAT. If I do not give you a base, you need to remember that the base was 10. Let's just say 100. Okay, so we'll play with that in this one. All right, so we are on page 7 then. Page 7 is just a whole bunch of more examples. So let's do this together. It says rewrite the following equations in exponential form. So I gave you the log form in all these problems, and I want you to go to exponential. What, again, the key to remember is write down how to go from one to the other. So write down log base b of x is equal to y. Write that down. And I'm going to write the double arrow to go from one to the other. That's the same as equaling y, or b to the y power is equal to x. So always write that down. For your whole go formative today, that's the key. To go from one to the other, you need to remember this formula, which remember, you'll be at home or you'll have your notes either way for this quiz or test. So you don't need to memorize this, but you need to know to use this. To go from one form to the other, you need to remember this. So I gave you all of log forms, and you need to go to exponential form. So all of my answers for these 4 examples, all of my final answers should be in this form, because I was given a log form. Okay? So what I want you to remember for log form, when I have a log form, what I want you to remember is whatever is on the other side of the equal sign is your exponent. So what I always do is I always go find what's on the other side of the equal sign, and I write my exponent. It's always whatever is on the other side of the equal sign. I didn't even look at the rest of the problem. Not the log, it's not going to be the log. My log is not my exponent, of course, but I know that whatever's on the other side of my equal sign is my exponent. You just got to remember that. For problem C, I would like to change problem C, so please do so. Please change problem C. We are going to make it log of 4, log base 4 of 64 is equal to 3. So we are going to do all these problems, but right away, I always go find what's on the other side of the equal sign and write that that's going to be my exponent. Because as you do this, you are going to get better and better at noticing that the little number is always your base. So as I'm doing this, I know I'm going to go find my base. My base is 3, right? My base is 3 here. And your base is always the first number in your exponential form. So you'll get really comfortable with that really soon. So to write this in exponential form, my first number is going to be 3. Then my y value, whatever my y is my exponent. But really quickly, it is not, it's the y value in this log thing. So my log base b of x is equal to y. Y is always after the equal sign. So this is Y. So my exponent is Y. My Y is always equal to the equal sign. So Y. And then following this, it's equal to whatever the X value was. Here's the X value. In my log equation, log base B of X. X is what came after the base. So X is what came after the base. So in this problem, it is X. So this is my answer here. Any questions on that one? Okay, again, you will get very, very, very comfortable with this. Same thing here. I know that this is, so I need to find my base. So I need to find my base first. I need to find what my B is. So log base B. So the number that I write first is my base. My base was 10 because that's my tiny number that I have right there. 10 raised to the Y. The Y is whatever is set to the, whatever my log is set equal to. My log is set equal to Y, so my exponent is Y here, equals my X value. My X comes after my base. Remember, my base is over here, so equals X. Okay. Same thing over here. Now I have all numbers. I wanted to give you one with all numbers because that's more standard. But again, as soon as I see the problem, I know whatever's on the other side of the equal sign is my exponent. So I'm still keeping, I don't even need the equation anymore when I know that, because I know that my base is my first number that I write. So 4. I know that whatever's on the other side of the equal sign is my exponent to the third power, and then that's always equal to the X value. The X value comes after the base in a log problem, is equal to 64. And you should be able to put that in your calculator. That is true. 4 raised to the third power is 64. When you're working with numbers, you should come back with a true statement. 4 raised to the third power is equal to 64. Alrighty, now this problem gets a little different, and I'm going to try to trick you on your Go Formative too. Whatever is on the other side of the equal sign is your exponent, and that's still true here. So your base, my base here is the letter E, which is okay. E raised to my exponents, which my exponent is whatever's on the other side of the equal sign. Do not get confused that when you look at the equation, you're going to want to say that it's Y, right? You're going to want to say that it's Y because that's what the equation says. Well, it says, Miss Bishop, it says that Y is the exponent. No, no, no. It says that whatever is on the other side of the equal sign is Y. Y is whatever's on the other side of the equal sign. In this case, I have an X on the other side of the equal sign. So X is my exponent, and then my Y is going to be what comes after the base. Okay, any questions there? Alrighty. Same thing that we just did then. Now we're going to go to log form. So I'm giving you exponent, but you want to go to log. So again, keep in mind that I have, yes, so you just follow the formula? Absolutely just follow the formula. Absolutely just follow the formula. So I'm going to, now I want to go to log form. So I'm giving you Y, equals, I'm sorry, I'm giving you BY equals X. That's the form I'm giving you. You need to go to, I'm going to run out of room. Let me write it off to the side. What I'm giving you is BY equals X. You need to make it look like log base B of X is equal to Y. So now I'm giving you exponent form. You needed to make it look like a log. So all of your answers are going to have the word log in it. Same thing we just did though, start to find the patterns. You know that your exponent is whatever is on the other side of the equal sign. So my exponent is what's on the other side of the equal sign. So I'm going to go and find all my exponents. There's an exponent there. There's an exponent there. We're going to change C. I'm going to change the problem of C so that it is 3 to the 4th power equals 81. You're going to always see a lot of problems that have just numbers. So that's why I want to give you one. Please change the problem for C. But again, highlight the exponent and then highlight the exponent. First thing I would do is always find your exponent, because find the pattern. You know that your exponent is always on the other side of the equal sign in your log, right? In your log, y is the exponent in an exponential form, and y is always set equal to the log problem. So I'm going to have log base. The base is always going to be easy to find. It's always that big number, log base 5. The base in the exponent form is always the base in the log form. So b and b are the same. And then I always mix up which one goes next. Do I put an x or do I put a y? But then I remember, okay, my exponent needs to go on the other side of the equal sign. So then I'm going to remember, okay, my exponent here is x. It's highlighted in green. That needs to go on the other side of the equal sign. So then y must go here. I will be honest, still to this day, I still struggle with which one goes where until I remember that my exponent always goes on the other side of the equal sign. That's my answer. Because if you just follow the equation, you could get that wrong, because you could be like, well, Miss Bishop, the equation says x needs to go here, but here I have a y. You need to follow this part of the equation too. Y is whatever is your exponent. My exponent here just happened to be called x, but you still need to have your exponent be called y. Okay, so I understand that part gets confusing. But again, another one. I have log base. My base is 1/2. It's totally fine to have a base that's a fraction. Don't worry about it. And then I'm like, okay, I'm not all the way sure which one comes next. But then I remember my exponent goes on the other side of the equal sign. So I'm going to put an equal sign that I know I need. And my exponent here is y, so I'm going to put that there. Just don't forget to put this x somewhere, and your x has to go after the base. And that pretty much matches what I have there. Okay, same thing here. My base is 3, so I have log base 3. The bases are the same. And then I'm like, ooh, something has to happen here. Leave a spot, but I'm going to go equals my exponent. Your exponent is always on the other side of the equal sign. So then 81 must go here. Okay, everything gets a spot. 3 gets a spot, 4 gets a spot, and 81 gets a spot. 3, 4, 81. Okay, and then same thing here. Log, my base is 10 of, and then I'm like, ooh, I'm not sure what comes next, but I see my exponent. My exponent has to go on the other side of the 2 or the equal sign, so it looks like that. And then don't forget to put your y right there. That is correct. Also, you will also see, I will not necessarily take off if you forget to do this, but it is the same thing to say log of y, oopsies, y is equal to 2. You also do not need to put the 10 here, because remember, if there is no base, I know that you meant 10. I'm okay if you don't do it because it's going to take some getting used to, but I promise you on your SAT, this will be the only answer option on a multiple choice. That's right. This will not be a multiple choice answer on your SAT. it will not show up with a 10. You will need to know that this actually was the answer to pick on the SAT because no base means you had a base of 10 there. Alrighty, so maybe a rocky start, but it's not that bad. Once you can remember those little tips, it's all about the exponent. The exponent is the key indicator on where everything else needs to go. The base is an easy one to pick out. The base is an easy number to pick out, but it's very easy to get mixed up what the x and the y are, but go with what the exponent is. Your exponent is always on the other side of the equal sign. So if I give you log, go find what's on the other side of the equal sign and make it an exponent. And if I give you the exponent, go put it on the other side of the equal sign, and vice versa.